Okay, welcome back. I hope you had a good break and are all relaxed and ready to go for the final few weeks that we've got left together. I've changed the background just to give you something different to look at rather than the concrete wall that you were looking at before. We're looking at the sixth stage of the product life cycle of a garment, which is one that we're all familiar with because we've engaged it either as customers or we work in the industry and have sold garments to customers. So either way, uh, we kind of know about it at one level. However, we're going to be looking at it from the social and environmental point of view. Um, in a traditional model, this is the one that counts. So managers, product developers would tend to see the other stages, raw materials, wet processing, etc., as being sort of in the background, not as important as the retailing and merchandising of the garment. However, remember in this model, all stages are equally important. They're all part of the journey of a garment. So where do we start? We'll start with, we're going to go through the stages of what we as consumers do when we decide we want to buy a garment. And the first thing we do internally, you might have covered this in your marketing, is we'll do a store search. And again, we're asking, as we go through each stage, what are the environmental and social consequences of doing that? So the search for information, as in the question is, which store should we go to buy our garment? There's a few different ways in which we do this. You know, one way is we ask our brain, or we search our memory, and we've got an association built in there for certain things. So if I say sports shoe, you might automatically say Nike. If I say cheap basics, you might say Cotton On. Now, marketers spend a lot of money trying to put that into our brains, so there's an association between a particular garment and a store. And the reason they do that is because that's the first place we look. We try inside our brain, in our memory, and ask ourselves, do we know which store we should go to? Notwithstanding that, let's say we don't know where to go to for a particular store. We might then apply word of mouth and ask our friends, associates, colleagues where they think we should go to purchase a garment, or we could go online, jump on the internet, or perhaps look at a catalogue that's in our mailbox or it's floating around somewhere, and we could look at that. So each one of these uh, different means of communicating what's available for sale has environmental and social consequences. What is true though in terms of trends, if you look at this chart down here, which displays apparel sales and the influence by different sectors, the blue one is offline sales. So it's a few years old now, but from 2004, the influence from offline information has been pretty dramatically declining and being replaced with online web-based information. So it's telling us what we already know. If you want to sell clothes in the 21st century, by and large, it's got to be online, or the information about that garment. So the, I'd sort of argue that the bricks and mortar store is becoming less important, and the information that's online is becoming more important in influencing consumers as to whether they should consider your garment or not. But if we look at the first one, word of mouth, and this is a paper written by Sweeney and her associates a few years ago. A positive word of mouth message has a greater effect on people's willingness to use a service than does negative word of mouth. You might, as I said, done this in marketing last year. Um, People tend to trust each other's point of view when it comes to certain things. You know, where should I go to buy a good pair of shoes or something? Um, So it can be a healthy interaction there between two individuals, and that feeds into this networks of our social economy here, or it displays it that way. And you know, particularly in light of what's happening with us at the moment and the social isolation, um, you know, some people are finding it difficult not to be able to interact casually with other people on a day-to-day basis. So it's good for your health to interact. It's good to have a network of people around you to bounce off ideas about what a good shoe is, what a cheap shoe is, or an expensive shoe. Paper-based consumption, catalogues, is also another effective means. However, if we look at it from the environmental point of view, not so crash hot. Paper consumption per capita in Australia is 230 kilograms, and that gives us the gold medal for being the highest users of paper on Earth. We pip the Americans just by 1 kilogram per year, Western Europe by a considerable amount less, and if you look at Asia, which includes China, which is 1/5 of the world's population, they use hardly any paper compared to Australia. So as we know, paper comes from trees. Trees need to be planted on land. Land needs to be cleared. So there's a whole knock-on effect of environmental consequences simply to be able to create these sorts of catalogues in a hope that customers will come to our store to buy a garment or merchandise in that particular week. So it's probably one area in which Australia and businesses in Australia could improve by moving away from a paper-based communication tool to something more electronic, perhaps, or word of mouth indeed. The obvious one, therefore, is online, which, you'd think, oh, well, that doesn't use much resources, but, there's always a but, it does. It uses electricity. Your phone uses electricity. The website that you're looking at is stored on a computer somewhere on Earth. That uses electricity. And for the information to be sent across, uses electricity as well. So if we look at the data here, internet traffic accounted for 3.9% of worldwide electricity consumption in 2007, increasing to 4.6%, and it's obviously still increasing today. And that's on the back of 28 billion devices connected to the internet. Remembering our population is, I've got the chart here somewhere, where are you? World population is currently 7.7 billion, but we've got 28 billion devices, and that's because we've got a mobile phone, we've got a laptop, we might have a tablet as well, lots of devices, all of them using electricity. And electricity is a problem, again, only if it comes from coal-based sources. So if the electricity is generated by burning coal, coal emits carbon, carbon impacts on climate change. But if your electricity comes from another source, such as solar or wind, then it's not a problem doing it. The other thing it needs is water to run the internet and to store that information. So I'll start with a few videos to sort of give you a bit of a background as to where our information is, and just to let you know, your emails are all stored on what they call servers, which are basically big computers. Somewhere here. Where is it? So let's have a look at Google's servers to see how they work and how they store your emails.
Whenever you use a Google product, you're connecting to one of our data centers around the world. Let's take a look inside and see how they work. Google employees work here, keeping the data center up and running 24 hours a day. The networking room is the first stop on our data center floor. The equipment here routes requests to the right servers in the next room. These computers also allow our data centers to communicate with one another globally. On the server floor, powerful computers handle everything from billions of searches to hosting YouTube videos and protecting your email against viruses. We've custom designed these servers to be compact and energy efficient. To ensure you have access to your data whenever you need it, we keep each piece of data stored on at least 2 servers. We store another copy of the most important data on digital tapes. When a hard drive breaks, we erase all of its content. Then, for extra security, we destroy it with our disk crusher. The machines in our data centers are always working. cooling towers like these pipe in water to cool them down and keep them running. When the water heats up, we pump it back outside where it evaporates. Now that you've had a glimpse, walk inside yourself. Explore a Google data center with Street View.
So, as you can see, every time you generate a file, it needs to be stored somewhere, so these servers need to get bigger and bigger and bigger as we generate more electronic material. And along with that, water to cool these things down, because it's no different to your computer at home. You feel the back of it and it's quite hot. Well, these ones are much, much bigger and need more water. So as the information grows, so does water consumption. One solution that Microsoft have come up with, or that they're looking at anyway, is to put a server, this one, have a look at this one, underwater. Now, the idea is, well, what's that got to do with fashion? What's that got to do with us? Or how can we leverage off this particular pursuit? What we could do, we could choose to put our website, our company's website, on a Microsoft server where the information may or may not be served in these data centers, but you can use this as a promotional tool to say, well, this is part of our package of how we create a garment, how it's sustainable. Not just in the fibers and the dyeing process perhaps, but also in the way in which we store information about the garment itself and how we communicate with that. So these are ways in which you can sort of cleverly leverage off activities of other members of your supply chain and take advantage of that. The final one I'll show you is their data centers. I've actually got it here. So I'm jumping back and forth. This is just Google's website, and what you'll notice on their website is they start talking about renewable energy within their data center. So it's not the information that most customers that use Google, and in particular Google search engine, look at, but it's there in the background. And so obviously Google's taking it seriously, the amount of resources they use to keep their entire network going. And once again, it's something that our brand can leverage off as well by referring to it. So 3 examples of where electricity and water are demanded by consumers when they access the internet, and how 2 companies are trying to mitigate the problems, the worst aspects of it. We just have to find a way of sort of, as I said, leveraging off that. Okay, so to sum up the store search, the first stage in the pursuit of retailing a garment, there's impact on climate change, because we have to transport the information that requires electricity. We've got to use computers, requires electricity, and mobile phones and tablets as well also require electricity. Fresh water use, because we have to cool these computers which store all the information. Um, and fresh water is used when you create paper for these catalogues. So there's a use of water in that one. Land system change, you need land to build these computer servers on. That's part of the reason why Microsoft is looking at dumping them in the ocean, because it doesn't cost any money. You don't pay rent if you live in the ocean. You don't have dry feet either. Also, if we are going to use catalogues, paper-based catalogues, we need land to grow the trees on, and so that impacts on land system change. And finally, biosphere integrity, monoculture. When you do have tree plantations, you actually repel a lot of biodiversity in the forest, because all the trees are the same, you don't get the same biodiversity that you would get in a natural forest. Okay, so we've done our store search, and now we've decided we know which store we want to go to. Now we have to get there. We have to visit the store. And this requires two movements. And if you have a look at my little diagram here, that's us, the customer. We have to get to the retail store, and at the same time on the other side, you've got the garments also have to get to the retail store, so that there can be an interaction between the two. Customer can touch the garment, they can try it on. Each movement requires energy. So we're going to look at the consequences of moving people and garments to one geographical location, so that they can have a tactile retail experience. So the obvious one is the transport and CO2 emissions. And if we look at the pie chart on the left-hand side by the Stern Review, it's a UK-based paper that was done a few years ago. Of all CO2 emissions released into the atmosphere, 14% come from transportation. So, and as you can see, it's kind of an even contribution between transport, land use, energy, etc. And if we break that 14% up even further, we find that almost half, some 45%, comes from you and I driving a car or being driven somewhere. Hence the reason why there's a push for electric cars, because they're saying, well, if we can change the energy source of cars, then we may be able to reduce CO2 emissions. The complicating factor with that, of course, is that if you plug in your car to recharge in an Australian power point, chances are you're burning coal anyway to create that electricity, so you're not really solving the problem. You may be reducing it a little bit, but not solving it. Equally, if you plug in your car in Queensland, where the coal is black coal, which is cleaner, or New South Wales, the black coal is cleaner than Victoria's coal, which is brown coal, and it's very, very dirty, then that's even, just displays the problems we have when we start sort of saying, electric is better than petrol. It's not that simple. Depends which state you're in, depends what the energy source is. However, it is a step in the right direction. And that's, as I said a few weeks ago, sustainability is about incrementalism. We sort of slowly move in that direction. So we've got a problem. We've got our customer coming to the retail store, possibly by car, very possibly in the Australian context, and you've got the garments coming to the retail store on a truck, which again constitutes 23% of CO2 emissions in the transport component. And our challenge is, can we reduce that consumption down of CO2 emissions? The other problem that both the customer and the truck have is that they have to drive on a road, and a road needs land, and a lot of land. And when you lay down a road, what you do is change the ecosystem there as well. As you can see from this animal bridge, which was set up just north of Melbourne on the Calder Freeway, where animals would cross the road normally, and they run the risk of being run over by a truck. So they built this little bridge, so at night the animals can go across the bridge and don't run the risk of being run over. The other problem with, oh no, just to give you, I'll give you an example of the amount of land you need to build a road. Where is it? This is in China. I think it was after the Lunar New Year a few years ago. And these were people coming back from their holidays. Where are you? And, you know, this is probably the world's biggest traffic jam. There's So what we know about transport economics is the more roads you build, the more that they attract people to use them. The more that they attract people to use them, the quicker they get congested. So it doesn't actually solve the problem. It just, if you like, postpones the problem or defers it. The Americans stopped building freeways on a mass scale in the 1970s. The British stopped in the 1980s because they just found that it's, to some extent, it's a pointless exercise just trying to just build more freeways to solve a problem. It needs land, creates these sorts of congestions as well. So that's something we need to keep in mind, because if it's going to be harder for customers to drive to our retail stores, perhaps we've got to look at a new way of retailing our garments. If governments are going to build public transport, then that's great, but we've found, in Australia at least, governments are hesitant to invest in infrastructure for a whole range of reasons. The other thing that cars need, and trucks to a lesser extent, is car parks, and which requires space. So if you look at this image, overhead image of Chadstone, I think, or Knox, I can't remember now which it is. If you look at the shopping centre, the actual building itself, you'll find that the car park takes up almost the same amount of space as the building. So an obvious solution is to go up, but then that results in a more expensive building, which means higher rents for us. And because land is plentiful in Australia, there's a tendency to just, go out and build it. But it takes up more land as well. So conversion of land to car parks impacts on land system change. And obviously, if you turn, a virgin forest into a car park, well, then there's no room for the animals, apart from some